Hello everyone, I'm Francisco Cuadros from Metanogenia, and today we're going to see Lesson 4, Installation, Operation and Maintenance for Biogas System. In this video you will be able to see a process diagram of biogas generation system through anaerobic digestion of organic waste, example and explanation of biogas generation devices, the commissioning of this system, and the operation and maintenance necessary to extend the life of these facilities and obtain a good quantity and quality of biogas. This is a generic process diagram for anaerobic digestion. Organic waste is introduced into an anaerobic digester. Within this digester, and due to the action of a series of bacterial families, the degradation of the input organic matter occurs. In this device, it's important to control the temperature and agitation of the digester, so we will achieve an ideal bacteria balance and therefore a good gas production. The two outputs from the digester are biogas and fertilizer. Biogas must be stored in a gas storage to be able to dispose of it when needed. It's not necessary to pressurize the gas for its use. Must take into account that to burn biogas in a cook stove, it must not have excesses of overpressure, only at the amount necessary to exit through the holes in the cook stove itself. On the other hand, the digestate or digested sludge will have to be stored for its stabilization and subsequent dosage before its application to the soil. Stabilization is necessary to obtain a completely mineralized digestate with good fertilizing power. An autonomous biogas system device is shown on this slide. It's prepared to work with solar energy. This energy feeds the agitation and sludge transfer pump to the digester and the digestate outlet. The digester consists of a deposit, the green one, which whose temperature rises naturally due to the action of the sun. This device is designed for warm areas of the planet, where the digester doesn't need an extra heat input. This other facility is a small containerized anaerobic digestion plant. The entire process is installed inside a 20-foot container, which greatly facilitates the logistics of this technology. This plant is transported to the destination, and only a contribution of electricity, which can be a photovoltaic, is necessary to its function. In this section, we will deal with the key point of the commissioning of a small scale installation for the generation of biogas for cooking. First of all, it's essential to eliminate all water leaks and to ensure a correct commissioning. This is done by introducing water, which doesn't need to be potable, into the circuit, filling the digester and auxiliary tanks. In this way, and putting the installation into operation, we will be able to detect at which point water is being lost and act on those points. In the same way, it's necessary to do a technical test. This means checking that there are no points where the system loses gas. It is necessary to carry out this action to avoid losing a quantity of gas that must be used for cooking. First, the entire system is pressurized with a digester full of water with the help of a compressor until a pressure rise is observed on the digester manometer. A tire inflator, a compressor, is enough to do this. Subsequently, the entire system is closed and it's checked that the manometer doesn't lose pressure for a few hours. In the event that a loss of pressure is detected, it means that there is a point where the gas escaped. To detect this point, it's necessary to apply a soapy solution to the entire gas line. If there is a leak point, bubbles will form revealing the leak point. Once located, it's necessary to act on this point by applying insulating and sealing materials. Once it had verified that plants have no liquid or gas lucid, it must be emptied of water in order to incorporate the acclimatized inoculum. Organic waste contain a very small amount of anaerobic bacteria. This makes it very difficult to start the biological reaction with this byproduct. Ideally, if you do not have an acclimatized sludge from another biogas plant, animal sludge can be introduced to the reactor and water if necessary. This will provide a higher amount of bacteria. but commissioning will be slower than if digestate from an operation biogas plant is introduced. Once the sludge has been introduced, it is necessary to homogenize it inside the reactor, as well as adjust its temperature between 35 to 40 degrees Celsius. In this way, the degradation of organic matter will begin and the anaerobic processing will begin to take place. You have to be careful in the first week of commissioning, since you have to adapt the bacteria to the new substrate. This is done by feeding the anaerobic digester, little by little, not allowing an overload to occur. Consequently, biogas production during the first weeks will be close to zero, but little by little, they will increase as the bacterial population develops. This section describes the main process control variables. Organic loading flow rate, the amount of daily organic matter that must enter the digester to maintain bacterial health and the stability of the anaerobic process. About this daily flow, there is a danger of inhibition due to organic overload. This flow rate depends on the type of waste that we are going to introduce into the reactor. pH, the optimal value is 7.5. Below this value, there is a danger of reaching inhibition. It's the easy measurable value to obtain enough information about the stability of the process. The pH is measured in the digestate as soon as it's released in the digester. Biogas production. The amount of gas obtained can be measured daily with analog gas meter, both flow meters and gasometric devices. The decrease in gas produced is an indicator that something in the anaerobic reaction is not working correctly. Last but not least, it's important to know the basic maintenance points of the small-scale biogas production plants. The first place is essential to periodically check the condition of the pipes. As the months goes by, substrate can build up in spots and compromise the system. This action will be carried out isolating the digester and opening all the pipes for cleaning with water. Biogas is a gas that has a certain level of humidity, which condenses until it's used in kitchens. If we want that the calorific value of biogas to be as high as possible, we must eliminate that condensed water. This is done by having a tap at the lowest point of the pipe, which is where the water will collect. Doing this action every few days, we will never leave this tap open, as we will lose the amount of the accumulated gas production. As in the commissioning, it is necessary to carry out a thickness test to verify that we are not losing biogas. Again, soaping water will have to be applied throughout the pipe to check if bubbles formed at any point are formed. If there is no bubble formed, it means that we are using all the gas that we produce in the cookstoves. In addition, this soapy water can be used later to clean the exterior of the whole installation. Thank you very much for your attention.